Hello, my name is Nigel Bowden. I'd like to welcome you to episode 21 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi to build your understanding and knowledge of wireless LAN networks. Each episode is accompanied by a set of slides describing the topics covered in that episode, and although you don't need to review these slides while listening to the podcast, they may be useful for reviewing the material we discuss and may provide some visual aids to help you more fully understand some of the concepts and the equipment that I describe. All of the recordings and supporting materials can be found at wififorbeginners.com. This is episode number 21. The actual podcast series itself is divided into a number of major modules, and there are multiple episodes within each module discussing a major topic of wireless LAN information. In this particular module, module 6, we're looking at wireless control and management, and this is actually the third episode in module 6, so you might want to go back to episode number 19 to hear the first part of this module. Also, throughout the series, you do build on concepts from earlier modules, so if this is your first time of listening to the podcast, you might want to go back to episode 1 and listen to the whole series to get all of the various concepts and the information that was presented since the start of the series. Well, before we start looking at new information in this particular episode, we'll do a quick review of the topics covered in the last episode. We took a closer look at the control plane, the management plane, and the data plane, which we find within wireless LAN infrastructure. We talked a little bit about the management plane, about the fact that this is often split between a dedicated centralized network management system, and we also use some management functions for management of APs from the wireless LAN controller itself. The management plane is typically used to deliver fixed configuration settings to wireless LAN infrastructure equipment, things like SSID names, VLAN settings, 802.11 amendment support, security methods, things like that. And the concept of providing all of these functions is known as the management plane of the 802.11 network. And as we discussed previously, this is often split between a combination of a dedicated wireless management platform and the management functionality of the wireless LAN controller itself. Very often, the management platform will provide SNMP queries through to the wireless LAN controller, which acts as a proxy, passing on management settings to the wireless access points themselves. In addition to the management function, we also discussed the requirement for a control function within a wireless LAN environment. This function is known as the control plane of the wireless network, and it's generally provided by something like a centralized wireless LAN controller. The wireless LAN controller is very well placed to provide a centralized control function as a global view of the network, so it can make these centralized decisions and coordinate all of the activity across the wireless LAN infrastructure. We also mentioned that the centralized wireless LAN controller is not the only option for the control mechanism. We've also got the solution from AeroHive, which provides a distributed control system amongst APs and is actually a controllerless solution. We also briefly mentioned the data plane within wireless LAN infrastructure. This is the actual physical and logical path which is taken by the user traffic which flows across the wireless LAN network. We've got a number of options in terms of the implementation there, and we can actually have centrally switched or locally switched traffic, which we'll be looking at in a little bit more detail in this particular episode. We also looked at a number of form factors for the implementation of the wireless LAN controller. We looked at traditional 19-inch dedicated hardware platforms. We looked at smaller branch level hardware platforms. We looked at cloud-based solutions where the actual implementation of the controller itself is hidden. It may be a hardware platform or a VM. It's just presented as a wireless LAN controller service, and these tend to scale from mid-sized enterprise sort of deployments down to SME type level. We also discussed virtualized implementations of wireless LAN controllers, where we can actually have a VM in the data center maybe instead of having a hardware platform, and we can sort of scale the resources of that as required. We also looked at dual function APs, which are APs which have got sufficient resources to act as both a mini wireless LAN controller as well as an access point themselves. And these tend to be used in branch SME scale implementations, where you can have one access point acting as a mini controller to a number of wireless access points. We also looked at unified access, where the actual wireless LAN controller functionality is built into the native OS of a switch device. clients. And again, we also briefly mentioned the fact that we don't actually always need a wireless LAN controller to provide our control function. We looked at AeroHive, which can actually distribute its control function amongst its APs in a cooperative control system. Okay, we're going to move into some new information now. We're going to dig a little bit deeper into some of the functionality that wireless LAN controllers will provide for us. If you're following along with the slide deck for this particular module, this is module number 6, and we'll be starting at slide number 25. One of the things we need to consider is the selection of the wireless LAN controller that is going to be suitable for our particular requirements. We talked about a number of different form factors which are available, and the selection of a particular model or architecture is going to be very much driven by our network size, things like the number of clients, the number of access points, the throughput requirements we've got for our wireless LAN infrastructure, and that's also going to be driven to a degree by the vendor architecture which is available for the vendor that's been selected for the solution. And just thinking back to some of the functions that we might need from our wireless LAN controller, we've got the functions we've already talked about. We've talked about the fact that we need a centralized coordination point for larger wireless networks. It becomes very difficult to manage and configure them once we get beyond a handful of access points. Things like the AP channels which are being used need to be coordinated, AP power settings. We need to think about things like roaming, moving security keys between access points. So security is a very big piece of that. But in addition to that, there are also other services which benefit from the centralized nature of a wireless LAN controller. Beyond that, we've also got things like the monitoring of clients which are connected across our wireless LAN infrastructure. We've got services such as Bonjour and Apple services. These are services which benefit greatly from a centralized system. We can have centralized services on the wired side of our wireless network which need to be made available across the wireless LAN infrastructure, and the wireless LAN controller itself can act as a Bonjour gateway, advertising those services out to wireless clients. Also, because we've got traffic which is perhaps centralized through our wireless LAN controller, we can do things like centralized traffic filtering, which can be very useful for content management. We can do rate limiting if we actually want to limit things like maybe guest networks. We want to limit the amount of bandwidth that they're eating up on our network. We can also do centralized packet inspection and make policy decisions based on that, and that's certainly very applicable to packet inspection and applying quasi policy decisions based on things like application that are flowing across the network, allowing us to prioritize various applications over others. Maybe mission critical applications need priority, and also very useful for gathering data about clients from access points when we're thinking about services such as location services, where we'd maybe like to track clients or devices which are moving around our wireless LAN infrastructure, and we can provide triangulation type services and allow the tracking of clients and devices, which can again be a very valuable service. And having all of that data centralized through a wireless LAN controller certainly helps in simplifying the whole data gathering process. So there are certainly some great benefits to having this centralized data flow, this centralized architecture. We also need to think about how our wireless LAN controller is actually going to connect into our wired network. Obviously, wireless LAN infrastructure is very much about getting wireless traffic onto the wired infrastructure so that we can send it along to all of the various services available across our wired infrastructure. And it will very much vary with the size and the topology of the wired network that we've got and that we're connecting the wireless LAN infrastructure onto. In larger enterprise campus type environments, we tend to connect it at the distribution or maybe the core layer of the network, often in a data center. And it will generally be connected by some sort of a gig Ethernet port or multiple gig Ethernet ports. Maybe we've got some 10 gig trunks we connect it up to, or maybe even some NBASE-T 2.5 or 5 gig connections onto our switched infrastructure. For branch environments, we've often got two options. We may well deploy smaller controllers at each of the branches and connect them up to the wired infrastructure at each branch, or we may have one large centralized wireless LAN controller at the data center with maybe some of the traffic switched out at the edge for local services. We also need to think about the connectivity of our wireless access points back to the wireless LAN controller. They generally form some sort of automated layer 3 connection back to the wireless LAN controller. The APs don't need to be in the same subnets or physically connected to the wireless LAN controller. They're usually installed somewhere remotely from a logical networking point of view, and they'll find their way back to the wireless LAN controller through one of a variety of mechanisms. We can use DHCP and DNS type mechanisms to tell the AP where it can find the wireless LAN controller. The AP just generally needs to get some sort of IP connectivity, and it will form some sort of logical tunnel back to the wireless LAN controller that'll pass its control traffic and potentially some of its user data as well. And the protocols we tend to use for these logical tunnels is LWAP, which is a Cisco proprietary protocol. We've got CAPWAP, which is more of an open standard for forming tunnels between access points and wireless LAN controllers, and some vendors also use GRE tunnels to connect their access points back to the wireless LAN controller. We've mentioned the data plane now a few times, and we've also touched on the concept of centralized switching and local switching. I just want to expand on that a little bit more now. This is one of those occasions where I'm going to ask you, if at all possible, to maybe have a look at the slide deck, if you've got access to it, looking at slide number 28 and 29 in the slide deck. In case you haven't actually got access to it, I'll sort of just talk through it now, but certainly is worth having a look at when you get a few moments. And we actually show the difference between central switching of the data plane and remote local switching of the data plane for user traffic. So just thinking first of all about central switching, if you can imagine, we've actually got wireless devices, our wireless clients talking to a wireless access point. The wireless access point itself has actually built a logical tunnel back to the wireless LAN controller. As I said previously, it's generally something like a CAPWAP or an LWAP type tunnel. So we've got connectivity between the access point and the wireless LAN controller. And then over this tunnel, we generally pass control traffic between the access point and the wireless LAN controller. But we can also take the user traffic from our clients and pass it through the tunnel and send it all the way through to the wireless LAN controller. And then at the wireless LAN controller, it can be dropped out onto a VLAN which resides locally at the wireless LAN controller, and it can be switched onto local services near to the controller, which is generally going to be in something like a data center, or it can be sent out towards the internet to give the user internet connectivity. So all of the user traffic flows from the wireless client through the AP over the tunnel between the AP and the wireless LAN controller, and then the wireless LAN controller drops it out at the centralized data center out to something like the internet or local services. I just want to contrast that for a moment with local switching. So in contrast to centralized switching, again, we have the wireless client devices which associate with an access point. The access point actually builds its logical tunnel back to the wireless LAN controller, and over the AP to wireless LAN controller tunnel, we have our control traffic as we did before. But this time, instead of user data going across the AP to WLC tunnel, it can actually be dropped off at the local access point onto a local LAN switch, so that the wireless LAN client at the local end of the connection can actually talk with local services. This is typically used in things like branch environments. So the traffic flow will be from a wireless client device through the access point onto the local switch at the branch, and it will drop onto a local VLAN to access local services within the sort of branch environment. We can also have a combination of the two, and this is a very common deployment. We can actually have an access point to wireless LAN controller configuration whereby we have traffic on one SSID which is dropped onto the local LAN infrastructure, maybe if we've got some devices which want to access a local branch service, and then we can also have a separate SSID which is maybe provided something like a guest type service where we actually have the client data which is sent all the way from the branch AP through the tunnel to the wireless LAN controller at the data center, and then maybe sent out to services in the DC or out to the internet to provide guest services. So two very important concepts there. We've got central switching where the client data goes all the way back to the controller, and it's handled at the controller end of things, usually in the DC. And then we've got local switching, whereby client traffic actually drops off on the local access point rather than traveling back to the central controller, so that it can access local services to the access point. And just to revisit the building of wireless access point tunnels again, we briefly touched on it a couple of slides ago, and just going to revisit it in a little bit more detail. So we talked about the fact that wireless access points have to build some sort of logical tunnel back to the wireless LAN controller. The wireless access point has to be given some sort of method to enable it to find the wireless LAN controller. So a typical sequence of events will be that a wireless access point is actually powered on, and it will actually get its IP address via DHCP, and it is possible to actually use DHCP options to pass back the address of the wireless LAN controller, so that the AP can find its way to the wireless LAN controller, build a tunnel, and start its operations. If we aren't passing back DHCP options, it's also possible to use well-known DNS names. So through DHCP, the AP will be able to access DNS, and it will use a pre-coded, pre-configured factory set DNS name that it tries to resolve, which will resolve to the IP address of the wireless LAN controller itself. It can also use some local layer 2 broadcast techniques as well to try and find a controller, but this is very rarely used these days, as APs are usually multiple layer 3 hops away from their wireless LAN controller, so layer 2 broadcasts don't actually work too well. And the connection from the AP to the wireless LAN controller, as we've said, is generally some sort of layer 3 tunnel, very much like a VPN tunnel type arrangement, over which we can pass the control and management traffic. And optionally, as we've said, if we're using centralized switching, we can actually pass user traffic between the AP and the wireless LAN controller over the tunnel. We tend to use protocols such as LWAP, CAPWAP, and GRE to build the tunnel between the AP and the wireless LAN controller. And once the access point has actually talked to the controller, the first time it talks, it will actually compare its version of code that it's running to the wireless LAN controller. And usually if there's a difference between the code that's running on the AP and the code that's running on the wireless LAN controller, then the AP will automatically download the code that the wireless LAN controller is currently running, so that it actually stays in sync from a version point of view with the wireless LAN controller. And using this mechanism, wireless access points always run at the same software revision as the wireless LAN controllers that they're connected to. Once it's downloaded its operating code, it'll actually generally reboot, which can take a few moments, and then it'll rejoin the wireless LAN controller using the same version of code, and then it can commence operations and handle user traffic. We've already talked in a reasonable amount of depth already about the data plane, but I just want to return to it for a moment now, just drill into a few more concepts which are quite important. We talked about the fact that having centralized data flows whereby all of the user traffic flows from the access point through the tunnel form between the AP and the wireless LAN controller all the way back to the centralized controller, which can be very handy for centralizing services such as application filtering, rate limiting, centralizing DHCP in one centralized point can also be very useful. And it certainly makes things a lot easier in terms of provisioning and managing compared to the edge provisioning and managing of these services. But centralizing these data flows doesn't always bring us all of the advantages that we might like. One of the disadvantages with centralizing data flows is that all of our user traffic is sent to the core. So if we imagine very large networks, all data from all wireless clients traveling back to the core may create fairly significant problems. We may not actually want all of the data to go back to the core. There may be some services which are local to the clients, and we don't want them all going back there. Also, the wireless LAN controller itself can actually become a choke point within the network. There's obviously only so much throughput and so much bandwidth that a single controller can provide, and then we have to maybe start looking at providing multiple controllers to split the load up, and then the engineering of the solution becomes a little bit more complex. We may also run into bandwidth considerations with centralized data flows, particularly when we start thinking about WAN bandwidth considerations. If we send everything back to one central point, we can certainly start running into WAN bandwidth problems. And due to these advantages or disadvantages of the centralized traffic flow model, Most WLC manufacturers provide two modes of operation for data plane. As we've already talked about, we've got the edge switched mode and we've got the central switched mode. Edge switched mode, as we've already talked about, it will actually drop client traffic onto a local VLAN, local to the wireless access point itself, onto the local switch. One point to note about this is because we're now actually dropping traffic onto a local VLAN, and we still have to provide management and control traffic back to the centralized wireless LAN controller from the AP. We've actually now got two VLANs which are being used by the access point itself. We usually have one for management traffic to go back to the controller and one or more to actually drop client data onto the local wired infrastructure. And for this reason, we have to bear in mind that our access point connection now changes from being an access port on the switch to a trunk, because we've actually got to carry multiple VLANs between the AP and the local switch. And as we discussed, with the centrally switched model, all of the client traffic travels from the AP all the way back to the wireless LAN controller and drops into a VLAN at the WLC. And in real-world deployments, we may often use a combination of the two solutions. Typical scenario is to use guest traffic centrally switched all the way back to the wireless LAN controller to access a common internet feed where maybe all of our content filtering and rate limiting is done. And then we may perhaps drop corporate traffic on the edge of the network near the access point onto the switched infrastructure at the branch end of things to access local services there. Thinking about a few other wireless LAN controller functions now, we've mentioned the ease of having centralized services with wireless LAN controllers when we think about things like radius services, DHCP, centralized security services. We can have firewall and ACL type functions implemented at the core of the network on the wireless LAN controller, and we can even have things like wireless intrusion detection systems, and this is all very useful stuff when we're considering the centralized data flow model of operation. As I say, very useful, very good for centralizing and managing these services. But when we actually start to think about these same services when we're using the locally switched model, whereby client traffic actually stays local to the AP, we need to bear in mind that these services very often need to be provided again at the edge of the network, as they're not centralized. The client data flow isn't centralized at the wireless LAN control. We need to push them out to the edge of the network, which does actually increase the administrative overhead of the wireless LAN infrastructure. We have to start thinking about making wireless access points individual radius clients instead of the radius client functionality being centralized at the wireless LAN controller. We need to push out firewalling and ACL configuration on a per AP basis, again out to the edge of the network. And things like DHCP helpers need to be configured on the local wireless LAN infrastructure, potentially near the AP, rather than all being centralized on the wireless LAN controller, which is one of the conveniences that we get with the centralized switched model. We're just going to run through one or two other miscellaneous functions that you may actually get from a wireless LAN controller as well. Think about things like wireless guest portals. If you've got some sort of guest solution, you maybe want to provide a coffee shop type Wi-Fi experience, then the wireless LAN controller itself may provide the guest portal where users are presented with a web login page and they enter their credentials, or maybe some sort of self-sign-up service to get them onto the guest wireless network. And very often these guest portals are simply a web page which may be customized with a particular organization's logo and color schemes. And in addition to the guest portal being hosted on the wireless LAN controller itself, it is actually possible to redirect to an external guest portal system so that the wireless LAN controller doesn't have to actually host it itself. It can be done on a third-party guest solution, and this opens up quite a few other possibilities for us. It means that we can actually push out the guest portal to a third party. It can be a cloud-based service, or it may provide other services such as limited time access or paid-for access to a guest network. Another service which might be provided by a wireless LAN controller and certainly lends itself to the centralized nature of the wireless LAN controller architecture is wireless intrusion prevention or wireless intrusion detection systems. These are very often built into wireless LAN controller solutions from many manufacturers, and the intrusion prevention or intrusion detection mechanism allows the monitoring of rogue devices, and these may be other wireless networks which are local to your wireless network, or maybe even access points which have been nefariously deployed on your wired infrastructure and actually present quite a security risk to your organization. The difference between the IPS and the IDS, that's intrusion prevention system, and intrusion detection system, is that the IPS system usually has some sort of proactive mechanism to allow you to deny service, to actually contain rogue devices. You can actually use wireless access points on your wireless infrastructure to perform some sort of denial of a service attack on access points which are classified as rogue devices. However, this is a function which it's not really advisable to use currently. There have been quite a few legal cases around containment using wireless LAN solutions, and it's probably best to consult your legal department before using those, as you could end up in quite a bit of trouble, as you could be perceived to be attacking somebody else's legitimate wireless network. And finally, just to round things off, just going to very quickly run through some of the pros and cons of some of the different wireless LAN controller architectures that we've discussed. This is just a list of items which might be useful for you to consider if you need to make a decision about whether to purchase dedicated wireless LAN controller hardware, or maybe a cloud solution or a VM. And so we'll just run through some of the pros and cons. So if we initially consider the traditional dedicated hardware wireless LAN controller platform, which we may deploy in our data center or maybe at our branch, it's still actually used in a large number of deployments, and it's actually particularly popular in large enterprise type deployments where it certainly provides the scalability that we want. In terms of pros, it's a very easy system to understand. Everyone can understand the centralized nature of it and the centralized control and management aspects. It's very easy to administer because we're actually administering the whole wireless LAN network from one central point, and the global view of the wireless LAN that it provides for us for making control decisions is very good. In terms of cons, there are a few disadvantages with the traditional hardware centralized controller. It is actually a single point of failure potentially, and very often we end up having to buy high availability spare to deploy next to our centralized controller. It's usually a HA spare, but again, this is additional cost. It can be cost of hardware, cost of licensing, cost of power and rack space, things like that in the data center. We've also got the ongoing costs of support and updating software in a wireless LAN controller platform that we maintain and install ourselves. And obviously we've got licensing considerations. We generally have some fairly complex licensing which is related to access points numbers and features we may have actually activated. If we start thinking about an alternative such as a cloud controller, this is actually still a controller function which is provided in the cloud. It could be a hardware platform or maybe a VM. It's completely invisible to the end user, but it's actually provided as a service. All of the APs still need to talk back to the controller, this time via the internet. We're not actually going over our internal network to talk to our own controller. We're actually having to get our APs to talk from wherever they are on the corporate network back over the internet to talk to the controller in the cloud data center. And generally a cloud-based controller solution will give us a web GUI which is going to provide us a view of our entire AP estate from one central point, as long as we've got our internet connection up. So in terms of disadvantages, the problem with the cloud controller is obviously if you lose your internet connection, you have no AP management, and you generally end up with a reduced feature set. There's also some considerations around security. Obviously, one of the beauties of the cloud controller is it can be accessed from anywhere where you've got an internet connection, but obviously, unless it's fairly well secured, the admin access to your entire estate can be accessed by a nefarious person if you haven't really shored up your security aspect of your admin access to the GUI which controls your wireless LAN infrastructure. And also you've got all of your control and management data, which is passing out of your own private network into the network of the service provider. The big advantages of a cloud controller are that you've got no controller to install, you've got no maintenance of a hardware platform, you've got the convenience of administration access from anywhere in the world, anywhere you've got an internet connection. You've got no ongoing hardware support challenges, it's all done for you in the cloud, and this is actually an operational expenditure, OPEX cost rather than a capital expenditure, so subscription-based models for this type of service are very attractive for many organisations. An alternative to a wireless LAN controller solution, as we've already mentioned, is the Cooperative control solution, which is provided by Aerohive. This is obviously a fairly niche solution, but we just need to be aware there is an alternative to using centralized controllers. Obviously, we don't need a wireless LAN controller for this solution. The APs use Cooperative control protocols to make their control decisions and to exchange control data. We still actually require a centralized management platform to push out configuration and software updates. So we do have a centralized management function, but no centralized control function. And this management function may be either cloud-based or an on-premise appliance of some type. The obvious advantages of not having a controller is you haven't got the costs associated with a controller. You haven't got to worry about licensing, power, hardware costs, ongoing maintenance. There's a whole raft of advantages to not having that piece of hardware sat in your data center. In terms of disadvantages, it's very difficult to come up with too many disadvantages. There arguably are some complexities around configuration. We obviously have to do a lot of configuration of services at the edge of the network, as opposed to having them in one central location that we get with a controller. Some would argue this is actually a good thing. We can actually push services such as firewalling out to the edge to protect the core of our network, but that's a bit of an ongoing debate realistically amongst wireless LAN professionals. But that's just a bit of a snapshot of the alternative to a wireless LAN controller that you might like to think about. Another alternative we mentioned was the dual function AP, where we've got an AP of high performance that can actually act as a wireless LAN controller or an access point. It's often used in smaller sites and branches. We've got one AP which is nominated as a controller. Maybe have one or more other APs which act as a standby, so that if the main AP fails, so we lose our controller, another AP will take over. The advantages to this is we don't have a central point of failure. If we have one AP which fails, which acts as a controller, it's only limited to one particular site or area. It's very scalable, very easy to deploy for organisations that have got many small sites, and also it's going to keep a lot of traffic off our WAN circuits. If we've got lots of branches or small sites and we don't really want too much traffic going back to the data centre, we can keep it all contained locally because all of the controllers are effectively out at each of the smaller branch sites. The disadvantage is that this actually provides us with a larger estate of controllers to manage, which could be a bit of a headache if we want to manage everything from one central point. The AP that's acting as a controller is going to be limited in the number of APs that it can manage, and also because we've got smaller scale controllers, because there are obviously hardware limitations to the access points compared to dedicated full-blown wireless LAN controllers, the actual functions which are available may actually be a subset of a dedicated wireless LAN controller platform. Well, we've covered an awful lot of material in the past 3 episodes. We've finally come to the end of our discussions on wireless LAN controllers, looking at wireless LAN management, control and data flows. We've covered an awful lot of material there, and I'm just going to very briefly summarise what we've covered in this module. We've actually talked about the need for management and control, and that was particularly looking at the scalability aspects of wireless LAN. Once we get beyond a handful of APs in our network, we need to start thinking about scaling things up in terms of a centralized management and some sort of control function to coordinate our access points. We also did an update of our reference model. If you think back to the very early days of the podcast, we had a reference model which was based on our standard edge distribution and core model, and we've sort of updated that to plug in the wireless LAN controllers at the distribution layer of our reference model. We also took a walk through the history of wireless LAN controllers. We sort of talked about the requirement for them, which evolved over time, and how wireless LAN controllers have evolved from dedicated hardware platforms right through to virtualized devices. We've got cloud services and even dual function APs now to provide the wireless LAN controller functionality. We also talked in some detail about the various concepts around the control, management and data planes of wireless LAN infrastructure. The control plane is providing our decision-making and coordination functions. We've got the management plane, which is providing the configuration management type options for our wireless LAN infrastructure. And we've got the data plane, which is actually the logical and physical pathways that our client traffic passes over to get access to the various services we provide around our wired network. We also looked in a little bit more detail about what we mean by a wireless LAN controller, particularly talking about the different form factors which are available. We also looked at wireless LAN controller connectivity within our network. We talked about the data plane paths and how wireless access points actually form their tunnels, connect back to wireless LAN controllers to provide control management and data paths. We also looked at a few other miscellaneous wireless LAN control functions, things like centralized firewalling, content filtering, guest portals, that type of thing. Some of the other lesser known functions that we need to consider, which we can also obtain by deploying a wireless LAN controller. And then we also looked at alternatives to wireless LAN controllers, and we looked at the pros and cons of various form factors and the various implementations which are available. Well, I hope this module has been of use to you. As I say, we've covered an awful lot of information, and certainly recommend that if you get a chance to have a look at the slide deck which accompanies this particular module, and maybe even take time to work through the module again. We covered a lot of ground, a lot of concepts. Some of them are very important as well when you're considering design and actually deploying your own wireless LAN infrastructure for enterprise type environments. Just like to remind you, if you'd like to get the slides for this particular podcast and any of the previous podcasts, you can visit my website, which is wififorbeginners.com, and there you can also find all of the accompanying quizzes and audio material which you can download for free, and various other resources which I'm adding over time to the website. Okay, well, thank you very much for joining me on this particular podcast. We'll be moving on to Module 7 in the next podcast, where we'll start to take a look at the very important topic of security in wireless LAN networks. Thanks so much for joining me. I look forward to joining you again soon on the next episode of the Wi-Fi for Beginners podcast.